Welcome back. This is part of my series on writing Python trading robots for use with Metatrader. In the last part, I showed how to run backtests on a strategy, but those backtests can only run in the backtest mode. You can't actually run the same trading robot to trade against Metatrader, because when you backtest inside Metatrader, it actually creates a virtual broker to handle all of the trading, and you don't get that when you're running Python. So today I'm going to show how we can modify the backtesting version so that it will run on both test and live. It's going to be a little clumsy. There is a lot of refinement to do, but I want to get to a point today where it at least operates in both modes, and then we can, in future videos, work on making that more generic and cleaner. If you haven't seen the earlier videos from the series, there'll be a link to a playlist in the description to this video. And the code today will also be shown on the web page, so there'll be a link in the description where you can go to the web page and see this code, so you don't need to worry too much about copying it down as I go through it here. To begin, I've simply taken a copy of the previous version, this folder 07 backtest part 1, copied that into 08 backtest part 2, and then I've changed the names of the files. So in 07 it was just called backtesting1, and the strategy file was simple_strategy. I've changed those. I've called the main Python file macross because it's basically an macross trading robot, and the strategy is macross_strategy. Along with that, in the macross strategy, I've changed the class name here to macross, and that means that in the macross.py I've changed the statement here from classes.macross_strategy import macross, and here in creation of the backtest, I've put the name of the new class macross there. That's all I've done to begin with. I'll make one other very small change before we get down to what this is really about. In the last video, I also mentioned that pandas TA, which I wanted to use for technical analysis, had a bug where it was incompatible with NumPy for NumPy versions from 2 onwards. Now, I'm sure that incompatibility is going to be fixed at some point, but as of the recording of this video, it isn't. So I can't use pandas_TA with NumPy versions 2 and later. What I did though was that I forked the pandas TA in GitHub, made my own fork of that, and I've implemented a very quick and dirty hack on it to make it work with NumPy version 2. And that's available for you to install if you like. I will also leave a link in the description and on the web page where you can install that for yourself if you want to use it. Just remember, all I've done is make a quick hack to make this work. I haven't put it through full testing at all, but I'm going to be using that today. And to do that, or as part of using that, the only effect it's going to have is previously I had this def SMA, which was the calculation of a simple moving average, where I calculated using a series and then simply calculated the mean on that. I'm going to replace this with the function from pandas TA. That's it, just the TA SMA, passing in the series, the length, and it comes back as a NumPy. If you do want to install my hacked version of pandas TA, and if you do, I recommend that in future you uninstall it and install the real version. These are the commands that I suggest you execute. To run backtests, we have this from backtesting import backtest. What I'm going to do to make this run in both a live and a test mode is I'm going to create a class that inherits from backtest, which will intercept basically all of the calls to backtesting, and depending on flags that you set, will either use the standard backtest for testing or will execute live trading. To do that, I'm going to create a new file here in the classes folder. I've called that custom_backtesting.py. So the imports I need in the custom backtesting.py, I need Metatrader as MT5, date time because I'm going to be creating date time type variables, pandas because I have some data frames, import time, I'm going to be using that to cycle through and run the next statement every certain number of seconds. These are some typing optional, tuple, type, and union because they're used within the backtesting parent classes. And of course I need the parent classes, backtest and strategy, which I'm importing from backtesting. So first I'm creating my class custom backtest, which inherits directly from backtest. And for the beginning of this, all I'm going to do is just basically implement calls back to the parent class. To begin with this, I'm going to create a constructor, and the constructor for this will have the same signature as the constructor from the backtest class. There it is. If you wanted to find this signature from the backtest class, you can just right click on backtest, go to definition, and that will open the backtesting.py file, and then you can find the constructor here. I've just copied that. And all I'm going to do initially is on call from here to the constructor of the parent class. I do that just with the super, and then I'm calling the init method, passing all of the same arguments that I'm receiving here. There are two things that I will need to add to this. Given that the purpose of this is to allow you to run in a test or a live mode, I'm going to set a variable here inside the class that tells me if you're in testing mode. And the default will be true, so I'm simply setting self is testing equals true. The other thing is that if you're running in live mode, you won't have a historical data set to pass in. So I'm expecting you'll pass none into that argument, but because that is then passed on to the parent, here I need to construct a dummy data set. Here it is. All I'm doing is setting up the columns as an array. I'm creating values for each column. I'm creating a special value for the time column. I'm converting it to a data frame, and then I'm setting the index to be the time column. So at the end of this block of code, I have a variable called data, which is this same variable, which contains a data frame that has basically one row of zeros. And I can then pass that, and this super init will not fail because I've now passed a valid data set. If I do want to run this in a live mode, then I'm going to need to make a call and set this is testing to false, and pass in some other information. I'll need the symbol and the time frame, for example. So I have a method set live params. I'm passing in a symbol, and I'm setting the default time frame to 1 hour. And cycle here, if you remember from earlier videos, is how long I wait between each iteration when I'm running through the loop. To begin with, if you've called this, then it's not in testing mode, so I'm just resetting that testing variable to false, and then I'm saving the symbol, the time frame, and the cycle in class variables. Next thing to add is the run statement. So if we go right back to the beginning here, after I've created a backtesting object, I then simply call run. The first test I have here, if is testing, then all I'm doing again is calling the run method on the parent class, passing the same arguments through. If it's not testing, then it will fall through to the rest of these statements. First thing to do in here is to check that this symbol that you passed in from up here is valid with the MT5 symbol select. And by the way, this expects that MT5 has already been initialized, which I do in the main code here, MT5 initialize. But if I can't select the symbol, then this will simply return none, and at that point, that's the end of processing. There are some statements that the parent class will execute in terms of setting up the strategy that I need to do here. Now this line is just to create a strategy variable, strategy object. It's of type strategy, the parent class, self._strategy. This is a constructor method. None self._data. _data is created earlier by the constructors here with the data set that's been passed in. And kwargs, keyword args, comes from here. After that, because I'm also telling strategy whether I'm running in live or test mode, I have again a set live params, which we'll see when we create the custom strategy. Symbol equals self symbol and time frame. So self and time frame are being passed into the strategy as well. After that, I need to initialize the strategy. So I'm calling the init method, which, although I haven't modified it yet, it would be calling this init method in my implemented strategy class. And then within this run method of the backtesting, or the backtest class, or custom backtest class, I need to call the next method on the strategy, which is what actually processes each data tick. So while true, because this is going to run infinitely, I'll have to just kill this script off when I run it. strategy.next, and then sleep for the cycle time that was passed in earlier. That's everything. I think that should be everything for the custom backtest class. Now I need the custom strategy class as well. Just as before, class custom strategy, it inherits from strategy, the main strategy class. I've defined a constructor here, which again just calls the constructor from the parent class, and I'm again setting this self is testing true within the custom strategy class. The set live params method inside strategy, I don't need the cycle, but I do need the symbol and the time frame, which I'm defaulting to a 1 hour and an empty symbol. And again, just setting is testing to false, because if you're calling this method, then you're not testing, and saving the symbol and the time frame. Now, those are the basics of what I need in the custom strategy class. But remember that within MA cross strategy, I'm doing things like call on buy and sell, which are intended to buy and sell trades in the testing mode. I need to override those so that if you're not running in testing mode, I'll actually execute the buy and the sell against Metatrader. There is also here this sum where I'm counting the number of trades, and I'm getting that from this self.trades collection within the strategy. But if I'm running in a live mode, I need to get that from Metatrader. So I'm going to create some methods that I can use to replace this statement and the buy and the sell. So just beginning with buy, and this is the signature that I've copied directly from the main strategy class. Self is testing, then I'm simply calling the superclass again, or the parent class. If I'm not testing, then I'm calling open position. Now this is a function that I wrote earlier. It will have some slight modifications. I'll go through those in a moment, but it's a function that I wrote in one of the earlier videos to this, which basically calls Metatrader 5 to execute a trade of this type. So I'm passing an order type buy because this is the buy function, with the size, the stop loss, the take profit. These two arguments are slippage and magic number, which I'm just leaving at 0 for now because I don't want to make this too complicated. Sell is obviously just the same thing, but here I'm passing in order type sell. This is the open position method from the earlier video, where I'm calling self.getRequest. That's another function again from the earlier videos where I create the request object. I'm passing in this type, the size, the stop loss, take profit, deviation, and magic. If request is none, which means that this failed, then I just return because you can't place a trade. And if I get to this point, then I call the MT5 order send, passing that request object. And then I'm just doing some diagnostics here, or printing some diagnostic messages. And I print the result in both cases, whether we failed or had success. Get request method, also from an earlier video, but this one has some modifications. I get the price information from MT5 with symbol info tick, so that gives me the current price. And if that gives me a none, then something's wrong and I can't proceed. So I just return none here, which will cause the rest of the stack to fail and not place this trade. Depending whether it's a buy or a sell, I get the bid or the ask price. The change that I made though from the earlier version, I previously had here a calculation of a stop loss price and a take profit price, because these SL and TP arguments were number of points away from the current price. But in this example, as I finish it, they will actually be the price where I want to place the trades, or where I want to set the stop loss and take profit. So instead of converting those to something else, I'm just using them here as the SL and the TP parameters of the request. And this has one more call, if not self.filling mode. Filling mode is a little bit more complex, and so I couldn't just set it as a value here. I'm setting it within this function. This is my set filling mode function, and I explained this in the earlier videos. But filling mode really needs information from the rest of the request to get the correct filling mode for this trade. I have two more functions that are both based on calling Metatrader. First is get rates from POS, because I want to get a list of rates, basically historical data from Metatrader, symbol, time frame, and the number of bars that I want to get. And this is simply using the mt5.copy rates from POS for that information. If I get none back, then I can just print an error message and return none. if I do get a response, then I'm converting that to a data frame, and I'm also renaming the columns to mixed case because that's what the rest of the backtesting system requires. And then I return that as a data frame. And the other method that I need in here, as I showed here, this count of trades needs to be a little different depending whether I'm in a testing or a non-testing mode. So my get open trade count is the function I'm going to be using for that. Just initialize the open trades to 0. If I'm in testing mode, then I can use those statements exactly as they were, which means that I can say sum1 for trade in self trades. If trade is long, this one should be as short. Too much copy and paste. And that just gives me the count of the trades that are either long or short, and I return that. If I'm not in testing mode, then I get a list of positions with MT5 positions get for the current symbol. If nothing comes back, then I can just return 0 because there must be a count of 0. But if something does come back, I then need to filter that for long or short trades. And it's a very similar statement to the one above. Sum of 1 for position in positions if position type is equal to the type in the argument here. And then again, I return open trades. I think that's everything for the custom backtesting.py. Now I've just noticed I do have an error here. This is incorrect syntax for the type of the position variable. It should just be position.type. Let's go straight back to MA cross. This is where I'll basically set up the backtesting or the structure to run in either a live or a testing mode. I'll add some global variables here first. I'll start out in testing mode true, so this will use historical information. I'm going to set the symbol to Euro USD, time frame to 1 minute chart, and the cycle to 1. Now, if I'm in testing mode, this information is not going to be used because the symbol comes from the testing data. But I have those there because I'll be using those if I'm not in testing mode. The next change here is this history data. If I'm in a live mode, I don't want to create this history data. So just change this. So in a live mode, history equals none. This statement then is the same, and remember, because history is none, it will go through that little block of code to create a dummy set of data. But if I'm not testing, then I need to call this set live params. So symbol equals symbol, that's where I've got these constants here, symbol, time frame, and cycle, time frame, and cycle. And I've set this for the demonstration at 1 minute because I want to really make this happen quickly. And then I have these diagnostic statements that print the result of the backtest, which I obviously don't want to print if I'm in a live mode, so I just put an if testing ahead of that. And I'll add an MT5 shutdown there as well. That's all that I need in here, and that's relatively simple because in this main part I expect to determine whether I'm in a testing mode or a non-testing mode and just make a couple of changes to the way I call things. I forgot. Also, I'm not importing from backtesting. I'm importing from my custom backtesting, the custom backtest class here, which means that down here, that's not, I change that to custom backtest. There are some changes that I need to make though in strategy. You might have seen some of these already, and there's some dirty code in here that I will fix in future videos. So in my MA cross strategy, I already have this import pandas as PD pandas TA. Remember I mentioned that. Be careful using this because of the hack that I've implemented. I've changed the import of strategy to import custom strategy from classes.custom backtesting. I'm also importing this backtesting._util underscore data, that's a class that I will need a little later in the code. And of course now the parent class for macross is not strategy, it is custom strategy. I'm going to change these so that I get a rapid result when I run this. These two statements I only want to execute if I'm in testing mode. And I'm getting this self.isTesting from the parent class, the custom strategy. So I can test that there, and I won't execute those when I've basically got an empty data set. Now down to next, let me do the changes inside this existing code first. So here I'm calling the getOpenTradeCount method that we've already described. And the same for the cell. I'm getting an error on MT5. I think, yes, I need to import Metatrader here as well. So that's the change. I believe that's everything I need inside the check for crossover section, which is basically the testing code. I need to make one more change here, and this is the really ugly code that I will be removing in future, because if I'm running in a live mode, then I'm not just going to pick up the data from self.data because it's history data and I haven't loaded that. And I also need to recalculate this fast MA. It's done here once at the beginning if I'm in test mode because I've got all of history ahead of me, and I can simply do a bulk calculation of the fast and the slow moving average. If I'm running in a live mode, of course, they're changing constantly, so I need to recalculate them each time I come in here to this next method. So if I'm not in testing mode, then I get this bar count, which I've explained before. I'm using the fast plus the slow period plus 3 just to make sure I've got enough data there. Then I call the get rates from pos, a method that we've seen earlier, passing in the symbol, the time frame, and the bar count. So that gets me a data frame of rates. And if nothing came back from there, then I'll return because I can't really do anything further. Now this self._data. Underscore data is not a data frame. It is actually an underscore data object. Underscore data is a class defined within backtesting. So to create this self._data, which is the main data that's used within the test mode, I'm passing a copy of the rates to the constructor for underscore data. That gives me an object which I assign to this underscore data. Note though, that is not the same as down here where this is just self.data, and that's because self.data is a method, so it's read-only effectively, but it does return this value. So that way, by executing this, I've populated self.data for close, open, high, low, anything I might need to use that is later in the code. So I'm basically creating all of this data up here in the testing or the not testing mode area. And then of course I'm calculating the fast MA and the slow MA with almost the same statement. I'm passing rates close and the fast MA period and the slow MA period. So now at the end of this block of code, I have populated data up to date. I have set up the fast MA and the slow MA, and the rest of this code then simply flows through. I think I've covered everything then. I know that was a fair bit to get through and I went through it fairly quickly. But as I say, this is an ugly piece of code and I can fix it, but it will take too long today. Let me go back to MA cross pi. So in testing equals true, I can run this once and I should just get the usual test results. And there they are. I've printed as before the history block and then the results from the test. If I change this now to false, close that to clean up, so I'll run this, and that's going to wait now. Here's the chart. I just need to wait until the moving average crosses. I don't know how long that's going to be, so I'll stop the recording now and come back when something's happened. Didn't take very long. Moving average has crossed. I've got a trade showing here, and over here I have my diagnostic statements. We had success and the result of the order that's been placed. So that's running, doing the right thing. There is some ugly code here, as I said. I'm going to stop that now. That I'll fix in the future, mainly because I want to keep the understanding of differences between processing between test and live out of the specific code for the strategy. So I'm going to remove all of this in a future video. I am traveling this week, so there may not be another video for a few days, but we'll definitely get to this soon. I hope this has been useful for you. If it has, click that like button because that helps me get views, and getting more views helps the channel to grow. And if you want to see more of these videos, click subscribe and then click the bell icon to get a notification when the next video is released.